This is Chapter 5, Social Emotional Development in Infancy and Early Childhood. So some of the topics we're going to cover here in this chapter have to do with the psychosocial stages by Erikson, Lev Vygotsky, and the zone of proximal development, theories of attachment, and we'll talk about the neurobiological predisposition for those or the neurochemicals that are involved. Development of emotional responses starting in infancy, the development of executive function, we've talked about some, changes in play as a sign of social development, psychosocial development and altruism, and the difference between prosocial behavior and altruistic behavior, and gender identity. Erikson is our principal psychosocial stage theorist. So he characterized that each stage of psychosocial development is actually the resolution of a conflict between a syntonic and a dystonic state. So the syntonic state progresses to the next stage, and the dystonic state is the dilemma that has to be overcome at each stage. Erikson proposes that stages are never completely resolved, that people continue to progress in psychosocial development all the way from birth or soon after birth, as soon as cognition comes in, and late life. So we'll actually be talking about the Erikson psychosocial stages all the way from infancy to late life. So this is the only stage theorist that really progresses all the way through the lifespan. So there are stages in childhood, the transition years, which are in adolescence, and adulthood. So you have early, middle, and late stage adulthood. So each of these has implications for the kinds of adaptations and transitions that have to happen at each stage to progress into the next phase of life. So let's look at early childhood and describe what Erikson meant when he discussed the syntonic versus the dystonic state. So the syntonic state is a sense of hope, so it's more future focused. You can see this when infants and toddlers adapt to strangers. You can also see it in stranger anxiety and the ability to overcome that. And it's described in Ainsworth's secure attachment, which we'll talk about a little later. The dystonic state is a degree of apprehension or dread, the anxiety that results with new situations that has to be resolved, and is described by Ainsworth's insecure attachment. So what we can say is people proceed or they resolve the psychosocial anxieties in the dystonic state to reach a syntonic state, or a sense of hope or confidence in the future, or efficacy. Attachment is at the root of psychosocial development. So this is psychosocial development at the most basic level, or the biological predisposition for psychosocial development. So there's actually a neurobiological basis for attachment in the brain pathways, and this is part of the evolutionary development of the brain to enhance survival by seeking nurturance and providing nurturance. And then that progresses to seeking social contact and providing social assistance. So the receptors in the brain that are responsible for this are on the D2 or dopamine receptors in the reward center. So they're part of the system that makes us feel reinforced for engaging in certain activities or in the presence of certain stimuli. In females, oxytocin plays a role in the formation of attachments, childcare and romantic attachment. In males, there's a similar neurochemical called arginine vasopressin that plays similar roles: romantic attraction, childcare, territoriality, and aggression. So that's why, and this is true across mammals. So it was first discovered in lower mammals like rats and mice, and then applied to higher primates like the great apes and humans. So in humans, some questions that sort of began the discussion of the neurobiological basis of attachment were in the process of looking at the effect of cocaine and opioid drugs on and the effects those have on attachment. Because it turns out that cocaine and opioid drugs, as well as other euphoriants, actually activate on that D2 or dopamine receptor. And the theory is that what could explain why parents, mothers in particular, abandon their children at so much higher rates than in the normal population when they're addicted to these drugs. The theory is that those drugs actually act on that dopamine receptor and block that receptor site. This sets up an interesting cycle, perpetuating kind of cycle in the addiction, and that is that the receptor site gets blocked off. That causes a kind of detachment, and so the person doesn't respond to the normal attachment drives or that they would with their own children or members of their family or other romantic partners. And so they behave in ways that are the result of that failure of attachment. So they develop sort of an acute attachment disorder. But what happens is that at the cessation of the use of those drugs, the attachment disorder recedes and the sense of attachment comes back. When the sense of attachment comes back, there's an aversive reaction because they can remember the behavior that occurred when they were in their attachment disorder, and so they get real strong feelings of guilt, regret, and loss, and that is a really aversive emotional reaction along with post-abstinence withdrawal syndrome. So that's why, as perplexing as it is, the instant cure for feeling guilty, detached, regretful, is to seek out the drug, eliminate those aversive feelings, block up those receptor sites, activate them with a euphoriant, and you get a very powerful negative reinforcing effects. And that sets up this cyclical pattern. So what we know about addicted moms and parents in general is that they have to get pretty far past the post-abstinence withdrawal syndrome, be abstinent long enough to address the aversion that comes from all of the behaviors that happen during the attachment. So what does that tell us? Well, that tells us that attachment forms beginning in gestation in females and continues to develop through the birthing process and in the process of taking care of their babies, as well as males. It also tells us that females aren't the only ones that form an attachment, because males have another process that is similar to what females have, and why you know, in other mammals you'll see aggression in males as well as females, territoriality and aggression in protecting their young. So this biological attachment, another consideration with it is that if, let's say, a mother wants to put a child up for adoption, you can't really know that they're going to be able to do that and follow through until after the baby's born, and they can actually turn the baby over. Some find that as they get towards the third trimester and they're in Braxton Hicks contractions, where they're secreting a lot of oxytocin, that they begin to form a biological attachment to the child, and that can make it, in some cases, much more difficult to release the child in adoption. Okay, John Bowlby actually observed what the research in attachment in animals had found, and with Conrad Lorenz and his work with goslings, he had laid out this process where goslings, a goose will sit on the eggs to hatch, and then once the eggs hatch, the goslings tend to form an immediate attachment to whatever organism is close by. So Conrad Lorenz set up this process where he would remove the mother goose, and when the eggs hatched, there are pictures of him walking along with the goslings following him. Well, John Bowlby was looking at this literature and the ecological nature of attachment in mammals and applied it to humans. So he spelled out the stages of attachment in humans. Now, Mary Ainsworth took Bowlby's stages of attachment, and she describes a variety of types of attachment. So the way she did that was she devised the strange situation method to observe and study types of attachment. And in that process, she managed to describe 3 types of attachment that she saw in the laboratory setting: avoidant attachment, resistant attachment, and disorganized attachment. And so you can also see this lays the groundwork for sort of understanding a failure of attachment and some dysfunctional attachments in kids. If you look at the juvenile delinquency literature and in the abnormal psychology literature, you can find articles and studies that reference failure of attachment in enduring psychological disorders. Now let's look at emotions and emotional development. Emotions are in a subcortical region of the brain, in the lower part of the forebrain, called the limbic system. Limbic, it means a ring, and it involves a ring of structures in the brain. So in the limbic system you have, and this ring of structures encircles the thalamus, which is the relay center in the very middle of the brain that relays 4 out of 5 of our senses to other regions of the brain for storage. So in the limbic system, you have the hypothalamus, which is responsible for drives like hunger, thirst, temperature regulation, and sex drive. And that is actually the link between the brain and the pituitary gland through the pituitary stalk. The pituitary gland is the master gland for the endocrine system, and it's actually not in the brain. It's underneath the brain in this kind of bony saddle in the skull called the sella turcica that protects the pituitary gland. So it kind of makes sense the way the brain's organized that it would have the drives. They're directly connected to the pituitary, to the endocrine functions. And the endocrine functions involve things like, insulin secretion, and adrenaline, and your regulators of all the body systems, and osmosis and fluid balance, and all those are all in the endocrine system, as well as all the procreative hormones. In the brain, there's an interesting kind of engineering in the brain, and that is that structures in the brain that are critical for survival tend to be well protected and deep in the brain. That's why you would see the limbic system, which is important for survival, is right in the middle of the brain, and it's completely surrounded by cortical tissue. So it is in an area of the brain that's the least likely to get injured. It's also in an area that gets its oxygen and blood supply before the outer cortical regions of the brain do. Another interesting thing about the organization of the brain with regard to survival is that things that have to communicate a lot tend to be very close together. And so right up against the hypothalamus is this structure called the amygdala. And the amygdala is where irritability and frustration, emotional reactivity are. Now, that kind of makes sense when you're looking at drives, because we all know that when babies get thirsty or hungry, they get irritable. So that sets up a emotional driver to get that need met. And that's why there's so much connection between sex, drive, and emotion. Temperature regulation is there because if you're uncomfortably hot, to the extent where that could be dangerous to your health, or uncomfortably cold, then that will fire off signals to the amygdala to seek out cool air if you're too hot, or warm air if you're too cold. In fact, there's something called hypothermic psychosis, where this was documented in World War II when soldiers were in the Ardennes and in regions where they were trapped in ice and snow without adequate equipment, that after a while sometimes they would become psychotic from the temperature. The Germans experienced that as well in Russia when they were trapped in the winter in Russia with nothing but wool gear on and no adequate equipment. So that's kind of how the amygdala works. And the amygdala is, to a large extent, in charge in an infant and toddler's brain, because the cortical structures on the outside of the brain, which we'll talk about later, are not developed, whereas the amygdala and most of the hypothalamus, the brainstem, and the limbic system are developed. So the brain, develops from the inside out. The hippocampus is the memory system that encircles the thalamus and involves a region where episodic autobiographical memory is, and that happens to be really close to the amygdala as well. And so that explains, or may explain, why experiences that evoke strong emotions tend to be stored with a very low threshold and retrieved really easily. That's why traumatic memories can be spontaneously retrieved, and that's why they're called intrusive memories. The olfactory bulbs are not part of the limbic system, but they lie under the frontal lobe there, and they're also very close to those regions where the hippocampus is and the hypothalamus is. And that's probably why what we find is that the sense of olfaction or smell elicits memories much faster than the other senses. So you have the limbic system there, and it develops first, but it's primarily a reactive structure. It acts on impulses. It acts in response to sensory stimuli coming in through relaying through the thalamus and the olfactory bulbs. And in early childhood, you have a underdeveloped or undermyelinated cerebrum. So that's why you find that infants and toddlers, childlike responses tend to be impulsive and reactive. So what's going to happen eventually as the brain myelinates, so the brain's going to reach about 90 to 100% of myelination by its fundamental myelination by 5 years old. Also, you're going to have neural pathways and synaptic pruning that are going to make the cerebral cortex much more efficient. And that's when you start to see and expect that executive function will improve. Executive function is the ability of the cerebrum to elicit control over emotions. So executive function gives you proactive planning, the ability to restrain and delay gratification, and so set goals. And those are some of the things that we prompt and expect in children as they get ready for preschool and kindergarten. Now, let's look at emotional development. So emotional development is a complex process, and that is, first of all, emotions start off as very basic, just almost reflexive responses. So at birth, for example, smiling is just a mirror neurons going off and causing a baby to imitate the expression on another person's face. But what happens pretty quickly is you get kind of an operant that gets set up, and that is that the infant will start to smile in response to familiar people or certain situations. And then within about 3 to 4 months, they'll start to reflexively laugh, mainly at visual stimuli that trigger that response. Now, laughing causes the release of dopamine, and so it's a pleasant response. It's also a signal to someone else that that person is not aggressive or on guard. So laughing is when someone's laughing or smiling socially, that's an attraction for someone else, and it's also a signal that they're not dangerous in any way, and that's what allows for social contact. Infants exhibit general distress to unpleasant experiences from birth, like being too cold, being too warm, being hungry, having pain in some way. They start to experience frustration within 4 to 6 months, and that's frustration is the thwarting of a goal. And even though they're not goal directed, they, if they're hungry and nothing's happening to satisfy their hunger, or if they're uncomfortable in some way and nothing's happened to satisfy that, or they're just not, there's not anything going on, and so they're in sort of a social vacuum, then they'll have a sense of frustration come from the amygdala, and that can cause an anger response, which is intense crying. They'll start to recognize faces and reflect those when they get to about 2 to 7 months. Their first fears, usually loud to startling kinds of events, happen at about 6 to 12 months, or fear of strangers. That's when in many kids, you'll start to see stranger anxiety, and that's going to precede separation anxiety. So then you start to see more complex emotions later on, within 15 to 18 months, like embarrassment, fear of punishment or disapproval, pride of accomplishment, wanting to be recognized, and those are higher level emotions that actually require some self-awareness. So there's this tendency for kids to develop a sense of me, not me, and that's all part of the decentering process that Piaget describes. So once they start to develop an awareness that their experience and someone else's experience are not the same, then they become more aware of their own emotions and their own thoughts. And that's going to be the initiation of metacognition. That is, you'll start to see very early forms of impression management, like modifying their response in some way to get a desired response. So after the development of object permanence, which begins the preoperational thought stage, you'll notice that toddlers will, they're just starting to decenter a little bit, and they'll start to look to caregivers or the people around them for cues as to how to interpret situations, mainly threats. So, but they may also look for cues as to how dangerous the situation is. So classic example is kids have big old heads and little bitty bodies, and it's not that easy for them to stay upright when they're trying to walk. So they fall down, and usually if they're not in pain, they'll immediately look at their caregiver. And the question on their face is, how bad is this? Or a stranger comes in the room and they'll look at a caregiver and the question on their face is, should I be upset? Is this a dangerous situation? And then what we do is we give feedback that is calming type language or an appearance of smile that signals them that, yeah, this person's okay. Or, mom may say when the child falls down, it's okay, get up. And then they, tend to comfort pretty quickly that way. But this is interesting. There's a feedback process here that can actually lower their pain threshold, because pain thresholds are lowered by fear and anxiety. So if a parent or a caregiver is a bit overprotective and overreacts to very minor little falls and things like that, the child can pick up on that fear from the parent or the anxiety from the parent, and they can actually begin to model that. And so they can develop sort of an exaggerated response to very minor incidents. And so it's kind of good for parents to sit back and take a calming response to non-threatening situations rather than being too quick to react. So with the development of the neocortex, you start to see the development of executive function. So executive function is the ability to elicit control over the limbic system or emotion. And that's evidenced in the ability to control impulses like self-restriction, delay gratification, like the ability to wait. Like if you say, give me a few minutes here. Goal setting and the ability to follow through and achieve. Self-calming when they're upset, and sometimes we cue them with that, like it's okay, take a breath. They learn to calm themselves. Later on, that's going to develop into the ability to change attributions, like decide that it's not so bad after all, or distract, or go on to the next thing. So that's executive control allows for the reappraisal of situations. Now, how they play also gives us some information as to how they're proceeding in social development. Like at first, toddlers just share space. They may observe each other, but they don't cooperate in any way. And so awareness of other kids, just observing the kids around them, sharing space is called parallel play. Parallel because there's parallel thought processes going on here. This progresses to simple social play when they start to interact and actually model or imitate the actions of another child. And then cooperative play is a much higher level, and that's when they start to imagine, role play gets involved, constructing or cooperating in the construction of something. And it's much more goal-directed and it's much more social. And this is actually what you begin to see progress pretty rapidly once they start preschool, because preschool prompts a lot of this. This is also playing around other kids in preschool at a very early age. This is before age 5, when the brain's myelinating, helps them build social skills, the ability to resolve conflict, the ability to tolerate differences in others, and to deal with socially induced standard normal range stress. So there are a lot of benefits to kids getting involved with social situations with other kids at a very early age. Let's look at the development of gender roles, because that's part of socialization. And that's a differentiating feature in the psychology of males versus females. But to really understand that, we have to get back to the nature versus nurture debate and really look at what aspects of gender identity are biological and predisposition and what aspects of them are social. because the interactive approach gives us a better understanding of the gender of gender socialization. So we start with just a little bit of review of the difference between sex and gender, which is sex is biological. It's, you have a Y chromosome or you don't. If you have one, you're a male. If you don't, you're a female. Everybody has X chromosomes. And so that is a dichotomous variable. That is, you either have a Y chromosome or you don't. So at a biological sex level, sex assignment, people are either male or female. And so what happens is the Y chromosome causes differentiation of the gonads during organogenesis and causes cells in those gonads to secrete testosterone, which is male hormone. Testosterone is the hormone that causes differentiation of the urogenital tract, which in almost all males, the urogenital tract is externalized. In almost all females, the urogenital tract is not externalized. So the way it works biologically is if you have a Y chromosome, you are a male, and the urogenital tract will be differentiated and the gonads will descend into the scrotal sacs. If you are not a male, then no Y chromosome will be there, no differentiation of the gonads will take place, and no differentiation in the urogenital tract will take place. So that baby will be born with internal genitalia, and we call those females. So now, gender is a little more complex, but not mutually exclusive, because gender it actually is not a dichotomous variable. It lies on a continuum from masculine to feminine. You can actually measure this with an instrument called the BEM sex role inventory. And what you find is that what's defined as masculine versus what's defined as feminine changes from time to time, and it varies a bit across cultures. So in a post-industrial society we live now, there are some traits that used to be assigned exclusively to females that can be shared by males, and there are some traits that used to be exclusively assigned to males that are shared by females. So we have more of a blending of masculine and feminine traits in males and females than we had in the past. Now, some people can call that the masculine-feminine mandate that came from when we were much more primitive in our, in hunter-gatherer societies and early societies where you had more distinct male-female roles, but industrialization has removed some of that mandate so that now females can share typical male activities and males can share typical female activities. So, but gender has biological predispositions from hormonal structural differences in males and females, and also in the hormones that are involved. Then what we talked about before, oxytocin in females and AVP in males. So we have another process that's part of the hypothalamic drives, and that's mate selection. So we have sex drive, and we also have mate selection. So mate selection falls on a continuum from heterosexual to homosexual. And it is not dichotomous, but it's highly dichotomized, and that is that most males select female mates and most females select male mates. So let's look at sort of the science of what the biological predisposition is for how someone falls along this continuum. And that is that in the hypothalamus, there's a region called the VMH, which is responsible for a lot of things. The hypothalamus is extraordinarily complicated. But what happens is that the theory is that the presence of testosterone when the brain is developing later in gestation, that the presence of testosterone destroys feminine substrate cells in the VMH. So in other words, the brain differentiates when there is testosterone in the system. And this was discovered in experiments with lab animals at first. And been, sort of verified now in functional MRI studies with humans. If the feminine substrate cells are intact, the female the person will select male mates. If the feminine substrate cells are destroyed, then that person will select female mates. So almost all, or the majority of males don't have much of their feminine substrate cells intact. They've been destroyed by testosterone, so they select female mates. And most females have feminine substrate cells intact, and they select male mates. But again, this is not dichotomous, it's dichotomized. And just like all differentiation is, after the Y chromosome does its thing. So that's why you can get some variance. And so some males will select either both males and females or male mates, and some females may select both males and females or female mates, and that lies on a continuum from homosexual to bisexual to heterosexual. So this serves as a biological predisposition. What's interesting is that it isn't necessarily completely consistent with masculine and feminine traits, because if you look at homosexual males, most of them, if you measure them with a BEM-sexual inventory, most of them still fall on the masculine end of the gender role, and if you measure female lesbians, most of them fall on the feminine end. So now you will have some feminine males and some masculine females, but a certain portion of those will actually be heterosexual. So what that means is that gender identity, the social part of it, doesn't necessarily line up completely with the biological part, that there is some separation between masculine and feminine identity and heterosexual to homosexual mate selection. Now, there are some gender differences that you can see in children in their play in early childhood, and these have some biological roots to them, but are also heavily socially influenced. So, and this is probably where you see more of a role of social influence and modeling, which is observation and imitation, than direct biological influences. So girls, for example, tend to engage in more enabling actions with each other, and they tend to be naturally more nurturing. Now, what are the biological predispositions for that? Could have something to do with, neural pathways that encourage nurturance, because they are the hosts for pregnancy and babies. On the other hand, enabling actions are also pretty heavily socially influenced, so they may be reinforced much more for enabling actions. And expectations is that they'll be helpful and nurturing and not as competitive. Boys tend to engage in more constricting actions. They tend to compete more. We know that testosterone does promote constricting actions and competition. And so there are some biological roots to that. However, it's also pretty heavily socially influenced. So boys can be socialized and to be more competitive. And there's a lot of highly competitive behavior modeled and reinforced in boys. So that can't be ignored. Also, enabling actions can be modeled and reinforced in boys, and they are more than they were in years past. Males are expected to be more nurturing and more enabling when it comes to parenting their kids than males in the past. They were pretty much dismissed from the parenting process in years past. And females can be in situations where competition is modeled for them and they're reinforced for being competitive. So females can be extremely competitive. So anybody's ever been to a sporting event that's where you've got high-level female athletes competing against each other, they compete in ways that are very similar to the way males compete against each other. So this, the social situation and context is setting up these behaviors that were previously considered gender specific, but not so much. There's also the tendency for permission socially in a post-industrial society or a more modern society for females and males to share gender characteristics, so without retribution or any kind of aversive consequence, as opposed to in the past. But of the two, males have a much bigger problem with having exhibiting any kind of feminine traits in absence of masculine traits, because bullying of feminine females, effeminate males, is a real problem in effeminate males. Let's look at the difference between prosocial behavior and altruism and the development of empathy and altruism in kids. Prosocial behavior is any behavior that benefits somebody else. So if you do something that benefits somebody for money, prestige, or some kind of prize or reward, that's still prosocial. So donating money, for a hospital wing is prosocial. Actually getting paid to help people in some kind of an occupation, like, being a social worker or a nurse or an aid worker. If you're getting paid and it's a career, that's still a prosocial behavior. And it may be partially altruistic. Altruistic behavior, though, is behavior that does not benefit the actor in any extrinsic way. So no reward, no pay, and altruism is basically an action that's based purely on empathy. So how do kids develop a sense of empathy? Well, that comes starting with decentering and being socialized and reinforced to take the perspective of somebody else. And we do that by prompting them sometimes. Like we'll say things like, how would you feel if somebody did that to you? And things like that. That's a prompt for empathy. And because it pings their sense of guilt a little bit if they've hurt somebody, if somebody prompts that. And so that's how kids develop a sense of altruism. Now, some people are extremely altruistic. So they actually self-sacrifice to some degree for others. And that's an action that's purely for intrinsic reward, has no extrinsic benefit.